Hey, welcome back. Today on Math Simplified by HM, we are going to tackle quadratic equations. Take a second to subscribe and hit that bell icon. After a brief polynomials recap, we will get started. Have your notebook ready? Let us go. The ascent of degrees, building from basic polynomials to the power of quadratic equations. The foundation of polynomials. An algebraic expression in one or more variables is a polynomial if the index or exponent or power of each term is a whole number. We read it again. An algebraic expression in one or more variable is a polynomial if the index of each term is a whole number. Polynomial includes one or more variables, coefficients to variables, and whole number exponents. If this condition is satisfied by any algebraic expression, then it is called as a polynomial. Example 3x plus 5. Here x is variable, 3 is coefficient, and 5 is a constant. And this expression forms a polynomial. Similarly, x squared plus 2x plus 3. Here maximum power is 2. So x square plus 2x plus 3 is a polynomial. Similarly, 3x plus 4y plus 6z is 7 is also polynomial. If the degree of polynomial is 1, it is called a linear polynomial. And if degree of a polynomial is 2, it is called a quadratic polynomial. As we have studied the polynomials, identify the whether following expressions are polynomials. Based on our rule, which of the following is a true polynomial? 2x raised to minus 2 plus 3, 4x minus 3x square plus 2. In first example, there is one term having negative power, which is not a whole number. So 2x raised to minus 2 plus 3 is not a polynomial. Second, 4x minus 3x square plus 2. In this expression, all variables have whole number and that is positive degree. So 4x minus 3x square plus 2 is the polynomial. So just as we have discussed, B is the correct answer and A is invalid due to the negative exponent. Again, in term B or in B polynomial, all variables power is a whole number and therefore B is the correct answer and A is invalid due to the negative exponent. Understand the linear equation definition. When a polynomial of degree 1 is equated to 0, it becomes a linear equation. We have linear equation standard form x plus b is equal to 0 where a is not equal to 0. Remember that when a will be 0, then ax from left hand side will go out and left hand side will become only the constant. And as per our definition, the left hand side must be a polynomial of degree 1. So, as per our definition, any polynomial of degree 1 is equated to 0 will become the equation when and when there is at least one term of variable having non-zero coefficient. Examples 2x minus 4 is equal to 0, 4x plus 5y plus 8 is equal to 0, x plus 2y plus 9z is equal to 0. We know how to solve the linear equations. For example, find the root or solution of the equation 2x minus 4 is equal to 0. Adding 4 both sides, we get 2x is equal to 4. Dividing by 2 both sides, we get x is equal to 2. And so the answer is x is equal to 2 or root of the equation is x is equal to 2. Now let us understand a quadratic equations. Its definition. When a polynomial of degree 2 is equated to 0, it becomes a quadratic equation. Its standard form is ax square plus bx plus c is equal to 0, where a is not equal to 0. If a equals to 0, then degree 2 term from left hand side will be vanishes and left hand side become bx plus c, and the equation will become bx plus c is equal to 0, which is linear equation. So any algebraic equation to become a quadratic equation, there must be at least one term of degree 2 having non-zero coefficient. Example, 2x square plus x minus 300 is equal to 0. Unmask the quadratic equation. Check whether the following is a quadratic equation. X minus 2 bracket square plus 1 is equal to 2x minus 3. As this is not in a standard form of quadratic equation x square plus bx plus c is equal to 0, we have to simplify this first. Expanding x minus 2 bracket square, we get x square minus 4x plus 4 plus 1 is equal to 2x minus 3. 4 plus 1 gives 5, so left hand side become x square minus 4x plus 5 is equal to 2x minus 3. Subtracting 2x from both sides and adding 3 both sides, we get x square minus 4x minus 2x plus 5 plus 3 is equal to 0. Simplifying, we get x square minus 6x plus 8 is equal to 0, which is exactly in the form of x square plus bx plus c is equal to 0. Therefore, in bracket x minus 2 bracket square plus 1 is equal to 2x minus 3 is a quadratic equation. By understanding the ascending degrees of polynomials and mastering their standard forms, we unlock the framework to solve the hidden structures of the world around us. As we wrap up our ascent through the degree of equations, I want to leave you with a thought. Mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. Just like we must simplify a complex looking equation into its standard form to find its solutions roots, we can simplify our daily challenges to find clarity. Thank you for your hard work today, and we will pick up with solving these quadratics after the break. Thanks for watching and keep up with that algebra practice. Before you go, please share this with your colleagues, drop a like and hit that bell icon. If you haven't already, make sure to subscribe so you don't miss our upcoming videos. Enjoy a great time with algebra.